In this section, we're going to talk about balancing chemical equations and what chemical equations mean. Before we even get started into balancing the chemical equations, we need to understand some terminology. The first thing we look at is that there's two substances on the left side of the arrow, which we call reactants. The two substances on the right side of the arrow represent products. You can have as few or as many reactants and products in a chemical equation. So why must equations be balanced? Well, it all comes down to the law of conservation of mass. Essentially, in a chemical reaction, you have to have the same amount of mass of each substance before the reaction as you do after the reaction. Here's a symbolic example of a balanced equation. Notice that we have 5 atoms of A over here on the left side as a reactant, and you have 10 atoms of B on the left side of the equation. So if we were to combine those two, you can see that we actually form 5 different compounds of something called AB2. So you'll notice that there's 5 compounds of AB2, but there's 5 A's and 10 B's still on both sides. If we were to write this out as a chemical equation, it would look something like this. 5A plus 10B yields 5AB2. Those large numbers that come in front of each one of these substances is called a coefficient. And once those substances are written down correctly, these coefficients are the only way you can balance a chemical equation. Let's look at a coefficient with a real substance. This is 3 calcium permanganates. So if you were to see a chemical equation and you saw a 3 in front of it, what it really means is that we have written it down 3 times. There's 3 different formula units of calcium permanganate. So let's go through the compound of calcium permanganate and see how many of each element there are. Notice that we have 1 calcium in calcium permanganate, but we have 3 calcium permanganates. So that would give us 3 calciums in there. The next one's manganese. Notice that there's 1 manganese inside the parentheses, but there's 2 parentheses. That gives us 2 manganese if there was just 1 calcium permanganate. But there are 3, so that gives us a total of 6 manganese. The oxygens, there are 4 inside of the parentheses, and there's 2 parentheses, giving us 8. So there's 8 oxygens per calcium permanganate. But there are 3 calcium permanganates, so we take 4 times 2, which is 8, times 3, which gives us 24 oxygens. Another thing you need to remember when you're balancing chemical equations or writing them out is that there's such things called diatomic elements. And the word kind of gives it away of what they are. It means there's 2 atoms of them in each of these compounds. Certain elements like to combine with themselves to make themselves more stable. Here is a list of what they are: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those elements, when they are found by themselves, will become diatomic and have 2 of themselves. A quick way to remember the diatomic elements is hexnohalogens. The H stands for hydrogen, the No stands for nitrogen, oxygen, and of course your halogens, which are group 17 on your periodic table. Let's go through a chemical equation here, and I'll show you a common mistake that some people like to make. The first thing I notice is that there are 2 hydrogens and 2 oxygens on the reactant side. And there are 2 hydrogens and only 1 oxygen on the product side. Well, due to the law of conservation of mass, that cannot be true. One of the big mistakes that students make is to change the formula of H2O to give us 2 oxygens by putting a 2 there. But as you notice, we have changed the substance now. That is no longer water, that is hydrogen peroxide, and you cannot do that. So the way to fix this is to put a coefficient in front of the water. That means we make 2 waters. But that gives us 4 hydrogens and 2 oxygens, and if you remember before, we only had 2 hydrogens and 2 oxygens on the left side. So what we do is we put a 2 in front of the hydrogen there, and now we have 4 hydrogens on either side and 2 oxygens, giving us a complete balanced equation. Let's go through another example. Now this one contains a lot of elements, so let's see how it goes. On the reactant side, we have 1 lead, 1 silver, 2 carbons, 3 hydrogens, and 2 oxygens. On the product side, we have 1 lead, 1 silver, 4 carbons, 6 hydrogens, and 4 oxygens. The first hint I'm going to give you is to save your oxygens for dead last. Save your hydrogens for next to dead last. So if you notice, of the 3 remaining elements, the only one that's not balanced are your carbons. You'll notice we have 4 carbons on the product side and only 2 carbons on the reactant side. Now the only way I can make the carbons balanced is to put a 2 in front of the AgC2H3O2. That now gives us 4 carbons, but it did change how much of everything else was in that compound. We now have 2 silvers, we now have 6 hydrogens, and we now have 4 oxygens. If we look now over here on the product side, we now have 1 lead, 1 silver. So the one that's not balanced now is only the silver. So to balance this out, we put a 2 in front of the silver. And now we have both sides equal in their amount of elements. Notice I fixed the carbon, which messed up some of the other elements, and then I just went through and fixed them until they were the same on both sides. Here's another one to try. Remember, save your oxygens for dead last, save your hydrogens for next to dead last. You'll notice we have 2 carbons, 6 hydrogens, 2 oxygens on the reactant side. On the product side, 1 carbon, 2 hydrogens, 3 oxygens. So we're not balanced. So let's start with our carbons first. I put a 2 in front of the carbon dioxide to give us 2 carbons on both sides. Now I go to the hydrogens. You'll see that there are 6 on the left side and only 2 on the right side. So I'm going to put a 3 in front of the water. That gives us 6 hydrogens on both sides and 2 carbons on both sides. The only thing we have left to balance now are the oxygens. And if you look, we now have 7 oxygens on the right and 2 oxygens on the left. The only one I'm going to mess with is the O2. And you'll notice that 2 goes into 7 3.5 times. But as chemists, we like to have our coefficients be whole numbers. So the way we're going to get rid of that 3.5 is to multiply all the coefficients by 2. The coefficient before C2H6 is a 1 right now, even though we didn't write it down. So if I multiply that by 2, I get 2. The 3.5 O2 multiplied by 2 is 7. The 2 CO2 multiplied by 2 is 4, and the 3H2O becomes a 6. Now you'll notice that all of the coefficients are whole numbers, and if we look at the numbers, we now have 4 carbons, 12 hydrogens, and 14 oxygens on both sides, a balanced equation. Balanced equations require some practice and just getting used to how to do things. But remember, the 3 rules are save oxygen for dead last, save hydrogen for next to dead last, balance an element, and see what it messes up within that compound. Fix it on the other side, and keep working.